students, myself Dr. Manju Banerjee, Assistant Professor Physics, Government Bilasa Girls PG College, Bilaspur. Students, today I deliver a lecture on laser-induced fluorescence, which is the topic taken from the laser spectroscopic technique of paper second, that is laser and laser applications of MSc 4th SEM. So let us see laser-induced fluorescence. We know that the phenomena of certain kinds of substances to emit light by absorbing various energies without heat generation is termed as luminescence. That means luminescence is the term related to the emission of light by some kinds of substances that emit light by absorbing various energies. Now, fluorescence is the phenomena which is linked with the time scale over which the light emission takes place. There are two terms related to luminescence. One is fluorescence and other one is phosphorescence. Now we discuss on fluorescence, and for simple light, it is the phenomena linked with the time scale over which the light emission takes place. Fluorescence is the luminescent process which persists as long as the excitation is continued. As long as the time is incident on the fluorescent substance, then we get the fluorescence light for that time scale only. Fluorescence thus refers to the emission of light with a radiative transition from an excited state to the ground state. Both states have the same spin multiplicity since the transition is spin allowed and they occur very rapidly. Thus we know that either here we see that fluorescence is the related with the transition from excited state to the ground state. The decay time of fluorescence is temperature independent. It is determined by the probability of transition from excited level to the ground state. That means fluorescence is independent of temperature and it is determined by the probability of transition from excited level to the ground state. Now, very significant fluorescent effects can be produced by illuminating various objects with ultraviolet rays from a mercury arc. Some fluorescence effects can be seen with the help of ultraviolet rays, and that is emitted from a mercury arc. When the light from the mercury arc comes through the glass, many organic and inorganic substances can be made visible due to their fluorescent light. That means many organic and inorganic substances can be made visible with the help of ultraviolet rays coming from the mercury arc, and that is due to their fluorescent light. Now let us see what is laser-induced fluorescence. For this, a simple experimental setup to record the laser-induced fluorescence is shown in the following figure. This is the view of experimental apparatus. Here see iodine fluorescence cell, L is lenses, M are mirrors, IRL is infrared lamp, CH is chopper, and PMT is photomultiplier tube. Now this experimental setup consists of a laser source, and for that a helium neon or argon ion laser will serve the purpose. The beam passes through the reflecting mirrors, a focusing lens, the sample cell, a mechanical chopper, and a monochromator. The detection of fluorescent light is done by a PMT, and that is photomultiplier tube, connected to a lock-in amplifier, then to a computer. This is the experimental setup, and the laser beam chopped mechanically at frequencies of 100 to 200 Hz, and it is focused by means of various mirrors or lenses into an iodine cell. In case of iodine molecule, which is pumped continuously to maintain a pressure of 10 to the power minus 2 torr using a simple rotatory pump. The laser-induced fluorescence of iodine can be observed by naked eye. The fluorescence is focused to the entrance slit of monochromator. Laser-induced fluorescence of iodine molecule is reproduced in the form of energy levels in the following figures. Here we can see the electronic transitions and the electronic level transition between B state and X state and the resulting spectrum. Here is the energy levels diagram for the B state and X state of the iodine molecule. We know that the laser beam pumps the molecules to a particular level in the upper state depending upon the pumping frequency. Once the molecules are in the upper level, that is to a particular rotational level J, they make transition to the lower state by spontaneous emission, and that is known as fluorescence. Following the selection rules. Here the selection rules is obeyed, that is delta J is equal to plus minus 1. Thus two lines are J minus 1 and P J plus 1 are possible. Thus we observe only two rotational lines, thereby reducing the number of lines of a spectra. From the upper state, the transitions are possible to the other vibrational states, giving rise to two lines, each with every vibrational transition. Thus, we could expect doublet transition in iodine at interval delta G, that is the vibrational quanta. Another setup for laser-induced fluorescence is presented in same type of figure. This study, that is laser-induced fluorescence study, yielded very accurate values of molecular data, which is very important in receiving the existing theories and to suggest new models in chemical bonding. Thank you, students.